Hi and welcome to my channel. Today, we will talk about the scientific revolution. The period in Europe between Copernicus and Newton is often referred to as the scientific revolution, when new approaches to science began to replace the Greek view of nature that had dominated for almost 2,000 years. The scientific revolution refers to a period of time roughly from 1500 to 1700 which witnessed fundamental transformations in people's attitudes towards the natural world. Scientific methodology was evolving and revolutionizing, based on the principle that progression in science would improve our understanding of the world. The period marked a watershed moment and would become a precursor to modern science as we know it today. In 1727, Isaac Newton, one of the key figures in the development of scientific methodology and experimentation, passed away. Over the previous 200 years, European thinking had evolved not only in science, but also in politics, philosophy, religion, and the art of communication. The Age of Reason, otherwise referred to the Enlightenment, was a movement that altered people's attitudes and views towards a host of ideas in politics, science, economics, and society more generally. This long process had begun with the Polish astronomer Nicolaus Copernicus, who in 1543 demonstrated that the Earth was not the center of the universe, an idea which had been embedded in the European conscience. Instead, he demonstrated that the Earth revolved around the Sun. Whilst this was a striking cosmological discovery, in fact it represented something much bigger. Copernicus's discovery led to more questions, not only scientific, but also challenging the values of society at its current status quo, as well as contesting long-held religious beliefs and teachings. The advances made by Copernicus in the field of astronomy were not isolated at the time. In the same year, as his publication explaining the heliocentric theory, the anatomist Andreas Vesalius published groundbreaking work on the circulation of the blood. This would mark the start of a long period of scientific progression across various fields including mathematics, astronomy, physics and biology, which continued to challenge and alter previous conceptions of the universe and society as a whole. In the meantime, shifting attitudes were impacting other spheres of life, including most pertinently for the period, religion. Martin Luther and the diet of the worms was causing a seismic shift in the Christian faith, realigning long-held views about the Bible and its interpretation. Furthermore, to add to these increasingly turbulent times was a technical revolution which enabled higher learning and communication to infiltrate and permeate people of all classes, a development that would massively benefit the scientific revolution to come. The printing press and its invention in the early 1400s allowed for the dissemination of knowledge to the masses, spreading the word in the vernacular and allowing for the printing of pamphlets, debates, arguments and posters that would incite debate and discussions. This revolutionary period would involve a host of figures from across the continent, including many from the British Isles. One of the most influential figures was Francis Bacon, an English statesman and philosopher who developed the scientific methodology, earning him the title Father of Empiricism. Born in 1561, Bacon was an important political figure and supporter of Elizabeth I and James I. As part of his new radical approach to knowledge, he proposed a scientific method that was based on observation and reasoning. Thus, hypotheses were to be proven or disproven through rigorous experimentation. The old accepted knowledge was to be challenged and tested in order to increase human understanding of the universe. Baconian methodology stated that information needed to be exchanged, that the state needed to play an important role, and that experimentation was key to the expansion of knowledge. As Bacon himself explained, Western progress was founded on three major discoveries: printing, gunpowder, and the magnet. Thomas Hobbes was an acquaintance of Bacon, and held a view which was startlingly new in its approach. He proposed using advancements in science to overcome the faults in nature and difficulties in the material world. There were figures close to the royal court who would make great strides in scientific discovery, including William Gilbert, who was court physician to Elizabeth I and James I. His hypothesis was on the principle of magnets, proposing that the Earth rotated on an axis because of terrestrial magnetism, an idea proposed 10 years before Galileo's publication on the same subject. England, and in particular the royal court, experienced a flourishing of talent in this period, with progress being made in a variety of fields. The astronomer John Flamsteed, born in Derby, would rise to become one of the most influential in the country, and in 1675 he was appointed the King's astronomical observator. With this warrant came the preconditions necessary for the foundation of the Royal Greenwich Observatory. Such was Flamsteed's expertise and influence. His work, Historia Celestis Britannica, which was published posthumously, would include some of the most accurate catalogues of stars, marking one of the most significant early contributions to the observatory. In the field of biology, it was William Harvey, the court physician to both James I and Charles I, who was to make a particularly important impact on the future of medicine. In 1628 he published his findings, after completing numerous dissections demonstrating how blood circulates in the body. William Harvey's discovery explained how the heart propelled blood through the body, a groundbreaking discovery. It is important to note, however, that these discoveries were taking place against a backdrop of great unrest and revolution in society, more broadly with civil disorder and the execution of Charles I. In England, the Civil War, which broke out in 1642 and lasted until 1649, led great change in politics and society. Nevertheless, this did not hinder scientific progress, as one might have expected. In fact, both sides of the conflict embraced the potential of science and technology and the positive impact it could have economically, socially, and politically. By 1660, the new natural philosophy, an interest in the sciences and how they work, had become fashionable across all social strata. From the exiled Charles II to the up-and-coming middle classes and even commoners, a new idea of sharing information, experimenting, and being interested in technology and science was blossoming. At this point, the sciences became institutionalized with the formation of the Royal Society. From its inauguration, the Society sought to research and innovate in all areas that would contribute to the advancement of science and technology. Notable members included Sir Christopher Wren, Sir William Petty, and Robert Boyle, to name just a few. Perhaps one of the best well-known figures was the president of the Royal Society in 1703, Isaac Newton. Remembered today as a crucial figure in scientific advancement, he published Mathematical Principles of Natural Philosophy, which provided the foundations for classical mechanics. In Principia, Newton would establish the laws of motion and gravitation that revolutionized the current understanding of science. The 18th century was defined by the great scientific strides made in the previous centuries, providing a backbone to the ensuing industrialization, which would come to dominate this new era. Science was very much embedded in the state, institutions, and culture of Britain, and in the coming years would help Britain rise in prominence.